Looks like we are all systems go. Yeah, your upload speed is not great. So again, once the recording finishes, Brian, just make sure you can walk away from the computer. Just make sure you leave that tab open, and it'll continue uploading in the background.
Yeah, I see like a percent uploaded, 720p percent uploaded. So it's uploading while we're doing the talk,
Yeah, yeah,
or it does.
yeah. It does it as you go. So like it writes to the hard drive and then uploads it like all in the background as we're going. Yeah, it says your upload's only
Okay,
like 3 or 5%, which is weird. Usually it goes to like 90 something percent.
I see that. I don't know what that means though. What is that? A percentage of what?
Like percentage of your total video file that's been uploaded.
So 100% would be like real time upload, kind of.
Correct. Yeah.
Like it uploads everything, it records it, keeps up.
Yeah.
And it's getting up.
That's getting there. It takes sometimes it
Let's go.
catches up with itself.
All right, I hope this. I hope we're able to complete the whole thing.
It's going, which is good.
So it's climbing.
All right. Vlad said he's looking for a room to hide himself in.
We are
Oh,
thinking about doing the podcast thing.
it's good, man. It's for our live stream audience too. It's a lot to take it from a brand new podcast to something that people are actually consuming. I'm realizing that that's probably the
Yeah.
hardest part, right? I benefited greatly from being really early with my Security Weekly podcast,
Yeah.
but without a time machine,
How do you do
it's
this? How do you market it?
yeah. I have like lists. I have like content growth plans. It's like so many things that we
Uh huh.
do. Social media is big. Um, Promoting at conferences was good. Anytime you have like big name guests, that helps kind of boost your audience. For my
Right.
Security Weekly one, they're playing around with Spotify advertisements. So they're putting ads in Spotify. You can put like a 30-second clip in Spotify to
Uh
advertise your
huh.
podcast. Um, I saw some of those results today from some of the shows they've been doing, and it's okay. Like, they're gaining like maybe 30 subscribers in a week or two, I think was the time frame. So it's helping, but
Hello.
it's hard. Hey, Vlad.
There's Vlad. Oh, that's cool. We got kind. We might have a superpower there if we like drop the links in our security advisories.
Yeah. Yes. Yeah. Organic,
So
like
we
to
could.
your
I
audience.
could
Sure.
like publish. Yeah, publish a security advisory and go, hey, come check out the video next month,
Right.
or just put the schedule in there what we're going to talk about.
Yep.
That'd be interesting.
All right. So this is episode 57, and it is August 13th. Okay. I'm just going to read a couple of things at the top of the show, Brian.
Yeah.
Let me just get this right. Brian, what's your title?
It's head of SSDLC organization
Head of
at AMI.
head of what now? That's the wrong keyboard.
SSDLC organization. So it's basically product security. We can talk about it when we get into
Yeah.
it. I can describe the functions of the organization.
Head of SSDLC.
Yeah. Secure software development lifecycle.
Got it. All right, you guys ready?
So that was a, yeah.
Yeah,
All right.
more or less.
Oh, Vlad, you there?
Yes. Do you hear
Oh,
me?
your video went. Oh, there it is. Oh, it says you stopped recording.
What?
Yeah. Why don't you try rejoining,
back,
Vlad?
but
Yeah, it's not recording your. Hopefully he rejoins.
he's in a restaurant, it looks like.
Could be. He's in
He's
our
at lunch.
Argentina. He's in our Argentina office.
Oh, he's getting some empanadas.
There he is.
Hello?
Now he's being recorded. I think you're good now, Vlad.
Mm-hmm.
All right, you guys ready? Alrighty, here we go.
Sure.
This week, Brian Mullen, head of SSDLC from AMI, joins us to discuss supply chain and firmware security. Stay tuned. Below the Surface, coming up next. Welcome to Below the Surface. It's episode number 57, being recorded on Wednesday, August 13th, 2025. I'm, of course, your host, Paul Asadorian. Joined by my co-worker, Mr. Vlad Babkin is here with us. Vlad, welcome.
Hello.
And before we introduce our fabulous guest for today, just want to remind everyone that Below the Surface listeners can learn more about Eclipsium by visiting eclipsium.com/go. You can find things like the ultimate guide to supply chain security, an on-demand webinar called Unraveling Digital Supply Chain Threats and Risk, a paper on the relationship between ransomware and the supply chain, and a customer case study with DigitalOcean. Of course, if you're interested in seeing our product in action, you can sign up for a demo at eclipsium.com/go. I am very excited to have our guest with us today, Brian Mullen, who is the head of SSDLC at AMI. Now, you probably know the AMI brand if you've ever paid attention when you're booting your computer and you've seen the classic American Megatrends logo come up, or you may have noticed what I call accidental digital signage in some public location. Not meant to be seen, but you look at a monitor and you're seeing a bio screen in a retail shop, amusement park, arcade, or what have you. Brian is with us today, shed some light on what AMI does and the amazing things they're doing to protect supply chain and firmware security and integrity. Brian, welcome to the show.
Hello, Paul. Thanks for the intro. So I run the SSDLC organization at AMI. And if you're one of the many people wondering what AMI is, we are an independent firmware vendor. And we sit in the firmware supply chain somewhere situated in the middle. We have a couple business models. We license our code to downstream partners, or we can kind of partner with downstream vendors such as ODMs and OEMs to create their derived product.
Yeah, Brian, I want
types
to stop you right there. So what's
Yeah.
the difference between ODM, OEM, and AMI? Like, what's the relationship there?
Well, we sometimes mesh them together and call them OXMs.
Yeah.
But ODM, original device manufacturer, and original equipment manufacturer. When you think of like an ODM, think more like a factory in Taiwan that's actually building the printed circuit boards, building the platforms. OEMs are like larger organizations that may perform some of the same functions, but they usually contract with the ODMs. So they're like your Dells or your Lenovo's or your HPs.
Yep.
And AMI is an upstream vendor in that whole firmware supply chain. So the OEM, let's just say OXMs, will come to an AMI or an IFV when they want to build a firmware component. So we have a lot of stable, trusted firmware for BIOS or UEFI products or BMC or hardware root of trusts. And they come to us to get access to that code, at which point it can be customized to fit their particular platforms. So with a little effort, they can tweak it and customize it to run on their platforms.
Yeah, it's I find it interesting. It kind of feels like the old saying that we have, like, don't write your own encryption algorithm or software. It kind of feels the same way for UEFI and BMCs. You don't necessarily want to take
Yeah.
on all of that on your own. You want to leave it to experts such as AMI, right?
No, like AMI gives it to you. It's 99% done. You just have to enable the
Mm.
security, add your own keys, and your own customization. So you may want to put your own logos in there and everything. Then you're off and running. You can flash that onto your platforms and ship that product.
And it's interesting from a supply chain perspective, all the things that go into that, right? I mean, we make it sound kind of simple, but there's a lot of
Oh,
moving parts in the supply chain
no,
just to get to a
it
point where you're
isn't. It
delivering a
is.
PC, right?
The supply chain's a beast. It's a very complicated supply chain. Lots of suppliers, lots of links in the supply chain, lots of disparate ingredients coming from different sources. So that kind of segues into the complexity of maintaining good supply chain security.
Yeah. So I guess let's start, Brian, with what are some of the things that you do? And we gained some insights into this. We have a report. I'll link it in the show notes. We helped AMI analyze the BMC software landscape. But what kinds of things are you doing, Brian, at AMI to preserve that software security supply chain?
Yeah, uh, daunting task sometimes. But
Mm.
this organization that I lead, SSDLC organization, it's responsible for proactive and reactive security. You can think of it that way. So proactive security is preventing security issues and vulnerabilities from getting into released products. The reactive side is, okay, you have a released product, vulnerabilities or issues have been found. How do you react to those? How do you remediate them? How quickly do you move on remediating those products? Which is a major KPI for reactive security. It's how fast do you move? I've been working with AMI since 2021, kind of maturing our security organization. Most of my focus has been on the reactive side. We have to get that stood up first and
Hmm.
matured first. But we're also looking at proactive security too. But lots of work have gone into the reactive side. So when I first came in, I mean, 2021, firmware security in general, I mean, a lot of focus has been put on that recently, right?
Mm.
So 2021 wasn't not too long ago, but when I came in 2021, we were kind of at one of those lower maturity levels. There was a lot of spreadsheets and emails being used
Right.
to communicate and remediate security issues. So I have a development background. So when I came in, the first thing I saw was like, okay, how can we modernize this? How can
Hmm.
we automate this? And we need to create it in a way that our operations can scale with the company's growth. First thing we wanted to do is, create a vulnerability management system where I could track all the vulnerabilities cited across the organization, all the products. And then I had to create processes that integrate that into the business units workflows so I could get that remediation information from them, process it, and then pass it on to the customers as fast as possible. So we've been cranking out we've been picking off little pieces of that ecosystem and optimizing it for the past couple of years.
Sure. I don't know if this is necessarily a dirty secret, but I don't think normal people don't look into UEFI security or ecosystems as much as the people on this call, right? But a lot of the code base is shared, right? Like, you've got the reference code, and then when that ends up on systems, a lot of that code is shared in common. Is that true?
Okay, well, there's lots of ingredients that go
Mm.
into the context of UEFI firmware. I mean,
Yeah,
it's
in
consistent
UEFI.
across different
Yeah.
types of firmware. But typically, you've got a silicon vendor component. So we get that from the upstream silicon
Right.
vendor supplier. And then for UEFI specifically, you've got this kind of like open source reference implementation
Mm-hmm.
called Tiana Core EDK2. It's technically open source code. There's some history there. It's like its custodian, I guess you could call it, its custodian is mostly Intel. So a lot of the contributors are Intel
Mm-hmm.
employees. And then other ingredients are just, just open source in general that we pull in. So you've got EDK2, you've got Silicon Vendor, and then you've got other open source, plus the AMI component, right?
Mm-hmm.
And
Mm-hmm.
then that goes downstream to the OXMs, and then they add in their special sauce.
Yeah. So yeah, you're right. There's a lot of ingredients there, and a lot of customizations.
Lots of ingredients.
And
Yep.
it's interesting from like an OEM standpoint, when a new vulnerability is discovered, for example, and we have to get a patch out that highlights the complexity of both the supply chain and all the
Uh,
ingredients in UEFI. And I think it was you, Brian, that said that OEMs want like a stable branch. They don't want to be experimental, because if something goes wrong in this particular software, it means systems aren't going to boot, correct? Potentially.
yes, that's nightmare scenario when your firmware doesn't boot. Yeah, they look for stability, and that sometimes the way to get stability sometimes conflicts with the security best practices
Right.
because uh, manufacturers are nervous, right? They don't want to change much. They want to kind of freeze that code base and keep it stable. They don't want to risk breaking anything. But in order to provide good security and keep that firmware secure, you have to patch it. You have to perform updates. You have to generate that churn.
Mm.
So they're stuck between a rock and a hard place, I guess.
Yeah, I liken it similar to the Linux kernel. If you've got a product that uses the Linux kernel, do you take all the security updates as they come out for that Linux kernel and apply every single one, or do you cherry pick, or do you
Cherry
modify or
pick, yeah.
customize, right? And it's some larger product, like Google is awesome with Android and taking in all the Linux security patches. However, Google's a massive organization with a lot of developers. You translate that
And
down to
lots of
UEFI,
testers.
right? You're cherry picking.
And
Mhm.
Yeah,
Yeah.
it
Vlad,
gets
sorry, you got
even
a
better
question
when
there?
it gets better when you think about libraries like OpenSSL. Imagine that gets a security fix in some later version. Now, do you take the whole of OpenSSL? Do you take just the security fix? If you want to take just the security fix, then
Right.
how do you do it? Like it becomes very complex very
It's a
quickly.
very good point. It's a very good point, and I actually sent emails directly related to that today.
Mm.
Uh, and I'm advising a practice of continuous integration. Everybody's at their own maturity level, right? You can't get
Mm.
everything at once, but start somewhere. Maybe you can cherry pick some packages, but if anything involves OpenSSL, let's stay with the latest and greatest because you're guaranteed to get all of the patches. It'll be supported by OpenSSL organization. You don't want to be using an EOL version of OpenSSL in your firmware, and then a major vulnerability is discovered in that, and then the only way to remediate it is to um, you know upgrade to a new version of OpenSSL. That's rather disruptive. And you don't want to be forced to do that because there's a lot of eyeballs on a celebrity CV that has just been discovered in your product.
Yeah.
So you want to develop those good practices, keep that OpenSSL updated to the latest and greatest.
Yeah, and it's OEMs have certainly a challenge, but everyone in the supply chain does, because as we update software, we could obviously introduce bugs into that, and oftentimes I feel like it's the Spider-Man meme where everyone's kind of pointing fingers at each other. Like a vulnerability comes out and they're like, well, whose fault is it, right? I feel like, and Brian, I'll speak for you and AMI. My opinion is sometimes AMI catches shade when you shouldn't, because I'm like, AMI fixed this. It's just a matter of the downstream folks picking that up and implementing it. But that's hard. Intel has the same problem. When we talked with Intel folks, they were like, we have the same challenges. So we put these great security controls in, these great fixes, but we're at the mercy of whoever's picking those up, and they have to then do their thing with it or not, and you don't have control over that.
Right. We do get the shade thrown on us. So, to give you an example, if we fix something 10 years ago, right? And there's some new technologies out there now where you can take a binary ROM image, perform some analysis on it, and that scan tool is capable of like fingerprinting it for certain vulnerabilities. Maybe it has the fingerprint for a vulnerability from 10 years ago. So that software is going to be finding those unfixed vulnerabilities in your firmware from 10 years ago, and then potentially, you're part of the next Black Hat presentation or something like that. So, and that could be the result of cherry picking, right? But you didn't. You thought you got the important ones, but you didn't take that medium CVSS scored issue, and then a researcher identifies that in your firmware product, goes to Black Hat with it, and then it's the new celebrity CVE of 2025, something like that. So that all goes back to cherry picking too. The best practice is to take all of the fixes your upstream providers are providing to you.
Yeah, one thing I really liked about your approach and AMI's approach, Brian, is you seem like you and your team are just like, let's get the vulnerabilities down. Like, we don't care what they are, just like total vulnerabilities. We want that number as small as possible, likely because of the scenarios you described, right? We just want to squash as many vulnerabilities as possible to reduce the likelihood that it ends up in anyone else's product.
Exactly. So part of an expansion AMI underwent in 2019 when HGC acquired us. We did create the role of CISO. So part of my function is reporting KRIs and KPIs to the CISO, and we pay attention to age of vulnerabilities in all of our products, and we track that, and that's like a monthly meeting with the executive team. So yeah, we don't leave anything in the products for very long.
Right. Yeah, and that's the right approach. But again, you still have to compel others to do that. But everyone has their own set of challenges. I think that's why yeah, and like as users and administrators, we're like, oh, there's a new vulnerability, and now I'm sitting twiddling my thumbs until someone else in the supply chain takes that patch, and then I have to then apply that patch, and sometimes that can take a really long time because this is really complex stuff, right? Firmware is just software that's inconvenient to program is one of my favorite quotes ever about the space, right? Yeah. I think it's complex, but also introducing a bug by introducing new code could have catastrophic results. Like the impact is super high.
Yes. So let's talk about that one case where you're twiddling your thumbs. So some OEMs down near the end of the supply chain, right? They get some security publications from the silicon vendors. So they could become aware that their product is affected by something at the beginning of the supply chain at the silicon vendor. But they have to wait for the silicon vendor to release the patch, and then maybe for the IFE to get it, to integrate it, to test it, to release the patch. And then they get it, and they do this, so it's trickling through the supply chain. Right. Maybe you're a CSP after them with a lab, and you need to update your data center. So that takes a very long time, and we're looking at ways to optimize that. But yeah, that was problematic because we work with researchers, and they're like, oh, we want to 60-day embargo, and I'm like, whoa, slow down. This is a complex supply chain. We have to give an opportunity to everybody in the supply chain to remediate this issue before we go public with it. So yeah.
Brian, I'm assuming that you've improved your processes for understanding when there's a new vulnerability, which likely of your customers may have that vulnerability, right? I'm assuming that's a pretty challenging thing to track through your own processes to go, oh, this vulnerability lives
No.
here, and we've got this many customers, or do you guys got that? It seems like you guys got kind of got that nailed, right?
Yeah, we got it nailed. It is complex, but I think we got it nailed pretty good. One of the greatest advancements, I think, right when I came in, is that we created a tool that programmatically identified which of our products were affected by an issue. So kind of we were relying on a lot of individual team leads to do the investigation and determine if they were affected. But we created this programmatic tool. We have like 98 active, around 100 active, we call them CRBs, these UEFI projects. Each one of them have many customers, right? So this tool could go through and find, even the EOL project actually could identify which ones had the issue.
Right.
But it would just run, it would go through the repos, find which projects are affected. So that was awesome. We've got that tied into our ticketing system now. So tickets are created for all the affected projects automatically. So yeah, oh yeah, and then one link down, the customers. So once the AMI projects are identified, we know which customers license each products. So we know which ones get the advisories to inform them of the remediations. And it's a need to know basis, right? We don't tell all customers about everything. Customers just know about what they need to know about.
In their affected products, right? Which I think as security researchers we appreciate, because we find a vulnerability. If it happens to be an AMI, I like that AMI can go, oh, we know exactly which customers, may be impacted by that. Like, we'll take care of it.
Right.
Rather than have us go, all right, well, we can go search through every UEFI image we can get our hands on and see if it's here.
Yes.
It's a much better
Yeah,
process
yeah,
when
yeah.
AMI helps. Yeah.
But
Go ahead, Brian.
but
And you have methods of doing that.
Yeah.
yeah, bigger problem is not even just this staying in AMI and vendors. It's also propagating this to customers of the said vendors. Like, let's think about a large data center. The large data center necessarily will have a lot of devices by a lot of different vendors. So you'll probably have HP servers, you'll probably have Gigabyte servers, you'll probably have Dell servers and whatnot. Now, how do you track all of that? So this is the harder problem, actually. I'm not sure if AMI can do anything about it, but that's an interesting
we've got a
question.
product for that. We've got a product for that. The DCM,
awesome. Yeah.
it's like Data Center Manager. So that can kind of be cognizant of the firmware running on the servers and be able to recognize when any of those servers are affected and, update, remediate. So there is a solution for that. There are also other advancements to kind of pull those CSPs into the loop. We have a big problem with remediations. I said the major KPI is the time to remediate, and we're looking for ways to speed that up. One of the things that takes a super long time, like a bottleneck, is the curation of the advisory documents, because that's manual, right? Right now it's manual. So we have to curate those documents, gather the information, put it in a PDF, publish that. We're looking to modernize how we do this, and we've just announced Meridian Services. And right now, we're going to build on it. There's a couple services available, SBOM and VMS, Vulnerability Management System. So this is basically a web portal you can log into, and you can have direct access to our vulnerability database. So you don't have to wait for us to get the information out of the database, put it in a document, go through the approval process, and then publish it, you get real-time direct access to the database. So we'll be building on that. I'm thinking about a services later where you can, you get machine readable advisories, which are popular, especially with like large OEMs that have to manage tons of projects. So envision like a information it's a VEC server, right?
Yeah.
You subscribe to your vulnerability status for your projects, and it pumps out CSAF formatted advisories for you. So that's kind of where I see this going. Right now, though, you can log in, you can see everything that affects your projects, you can download supplements, you can download the PDFs, or you can kind of view it in a web form.
Yeah, it's interesting. It's outside of AMI's control, but you mentioned end of life as well, Brian. And as we well know, and look, I don't want to throw shade at any vendors because we all have this problem. Any given vendor can't support a product forever, right?
Yeah.
There needs to be a juncture when that software is, and they call it all different things, as we know: end of life, end of service, end of support. And when it reaches that, you're not going to get updates for that as an end user any longer. And I think there's some great things happening in our industry, right? Depending on how you buy an enterprise product, you get better, longer support. That consumer side, we mentioned Gigabyte, like there's a lot of consumer manufacturers that are going through the similar process, but they're targeting PC enthusiasts and gamers, and that cycle's happening much, much faster. And I feel like that gear goes end of life much more quickly. I think because they expect that their end users, gamers and whatnot, are going to update more quickly, right? Have a much faster refresh cycle than your enterprise, right? Certainly.
Okay.
And therefore you find stuff that's just end of life. And then Brian, what do you do? What's your take on that, whole situation?
Well, AMI offers extended support for various products. So customers have that option. I just want to put this out there that the supply chain should be aware of, right? When we do, it's just realities, right? When you're supporting a product, through the life cycle of the product, you have different ingredients in that product. You go from release to release to release to release. You're updating ingredients from that complex supply chain, right? Mm-hmm. It's unrealistic to expect every single one of those versions of ingredients to be supported. So it's very taxing for an organization to try to generate patches for every single different I'm talking about ingredients in each release, right? So think about your different versions of OpenSSL. Mm-hmm. It's like, you didn't upgrade, so you're using that version of AMI code from 4 years ago. Oh, well, that's using an EOL version of OpenSSL. So I'm sorry, there's no patches available for that. We're going to have to help you upgrade all of OpenSSL. So good practices. Keep your firmware up to date with your upstream providers. It makes security much easier and much faster. So yeah, we do offer those extended support packages, and we have our product office kind of determines the policy on a per project basis when those go EOL. It takes into a couple factors, like is it like heavily weighted towards, is it EOL with the silicon vendor? So once the silicon vendor goes EOL, then we're like, all right, we need to think about EOLing this for sure. Also, like just demand. If there's little or no customers on something, then there's no point in having somebody there supporting it. But if there's heavy demand, we'll continue supporting that product.
Right. There's a few things that put pressure on that in the market. One is this switch from Windows 10 to Windows 11, right? In October, the Windows 10 is going to go end of life. There's going to be a lot of people stuck with older hardware, looking to upgrade to newer hardware. And then you've got the whole gaming. I don't know if you've been following. I know, Vlad, you're a gamer. Battlefield 6 has been in the headlines because they're enforcing secure boot in order to implement and enforce anti-cheat in their gaming platform. And this is like a massive industry. I don't remember what the number is, right? But gaming is a multi-billion-dollar industry. that hinges upon the integrity of the game that can be compromised if they don't do something about preventing people from cheating. And one of the solutions to that is secure boot. And now that they've enforced that, they claim, I actually just read an article that they prevented the 300,000 users or something like that from cheating just by enforcing secure boot and some other anti-cheat mechanisms in their games. But this all hinges on I've got a working supported copy of UEFI on my system in order to make sure it's all up to date and working. I got the latest keys. I mean, all of the ingredients, right, have to be in place
Right.
for this.
Right.
So
Right.
it's not even just that. Like, to be honest, all of this anti-cheat stuff is, in my opinion, very controversial. So first of all, those kernel anti-cheats are not gonna realistically do anything about like DMA attacks. Like
Right.
somebody just inserting something like a PCI leech, but imagine one that's adapted for cheating. Like I believe I saw a review of a device. One YouTuber just grabbed one of the cheating devices, and it was a literal PCI card to which you connect your mouse, and it just shoots automatically. And I believe that was Counter-Strike, but doesn't really
Right.
matter. You can do this for Battlefield, and you cannot really counter that. Then the statistics of 300,000 people being prevented from cheating. Question is just how many of those couldn't launch the game because they couldn't enable secure
Secure
boot,
boot. Right.
versus who of them actually wanted to cheat. So they probably inflated the numbers there quite a bit. And third one is, to be honest, the biggest one, and like it's kind of parallel to the discussion here, but all of those kernel modules they introduce, they're a massive privacy concern.
Yes.
Like
Yes, there is a huge
they
concern.
have they,
Right.
you are giving access to a game publisher which are not exactly known for having
Mm-hmm.
stellar security themselves to have a permanent kernel driver running on your system. And kernel driver can do a lot.
Right.
So that's no joke. And the question is, like, what can we do about this? And this can even start at potential vendors like AMI even. So there might be some modules to help Battlefield 6 not need the kernel module, right? So the question is just how possible it is for AMI to do something about this, how possible it is to create some industry standard. Because if you create an industry standard of that, people will be seeking for bypasses, and
Mm-hmm.
suddenly it will be affecting everybody. So industry standard in this case is not so great. At
Yeah.
very
Have
least,
you
that
have
would
you
be my
dealt with
thoughts.
the gaming issues, Brian, or is AMI more of like we set you up for secure boot, but then it's like kind of up to the OEM, right, to finish the secure boot implementation?
Right. We have dealt with the gaming issues actually. The pre-boot DMA attack vector
Mm-hmm.
that has come up recently. Um, so yeah, we had to work through those issues. It was due. The issue affected multiple manufacturers, and it was a configuration issue. It wasn't, you know, a vulnerability that it ended up being a vulnerability, but it was due to configuration issues. So
Right.
that's a whole nother topic. Is you know, how do we ensure that our manufacturers are configuring the security features properly?
Yes. I agree, and I think everyone that's playing in this supply chains. You've got the major operating system vendors. You've got Silicon. You've got AMI. You've got OEMs, ODMs. They all play into this. How do we make sure that everyone's implementing these security features? When I interviewed folks from Intel, they didn't want to like necessarily just come out and say, but there has to be frustration. You're building this awesome framework, great updated software, great security features, and then when the product hits the market, you're like, well, some of those security features didn't get implemented, and it's frustrating for me as from the security research side. I'm like, you have this platform, and you could have had great security, but you just chose not to implement these things when they were there. You just didn't use them. To me, that's frustrating.
Right.
In
You
this
have
case,
good security features. Go ahead.
I can maybe have a suggestion. I'm not sure how possible it is for the whole firmware supply chain because it's quite a bit more complex. But if you come from normal development, there is a concept called secure by default. And that includes a lot of things. Like, for example, just to give a very layman example that's very easy to understand. Like, what we have at Eclipsium is we deploy a platform, right, for our customer. Now, how do we ensure that they have some default logins that they can actually start using the platform with? Well, the default route is to have admin, right? Just some default user. But at Eclipse, we just decided, nope, we are not doing that. And during platform setup, we pretty much generate a user with a random strong password, right? So that's it. There is no default password. You cannot pick a default password because there is none. So
what do you do
maybe,
on the first boot? You generate a random password and just say use this.
yep. You
Yeah.
just say this is your
Yeah,
password.
okay.
Great. And maybe AMI can do something similar. Like, for example, again, not to put shade on AMI or any other vendor at that node, default security keys for binaries. They were seen in the wild being used by production firmware. What if there would be no default keys? Like, what
So
if
let's
That's a good point, Vlad. Yeah,
talk
Brian,
about it.
I'm curious to see how you feel about that.
So it's complicated, right? What it
yeah,
depends on the
it's
stakeholder, right? If we create a product, we want it to be usable, right? We want our customers to get our product to get up and running quickly. So that's one, and they want that. You want it to be able to build, right? You want it to be able to
yep.
boot. So anytime you start, like, all right, well, we got to be secure. So if you don't set it up securely, then we can't let you use it because then you'd be using an insecure product. We're going to force you to fix that compile issue because fixing that will make you secure, or tweaking that configuration so you can boot, like enabling secure boot or something. It gets very complicated because the downstream partners are responsible for configuring their security. We don't deal with keys. We're not going to give you your keys. There's lots of problems when we do that.
Yep.
So we're trying not to be a key manager here. So we rely on the customers to generate their own keys, to provision them into the security features, and then to get going. But a lot of them want to get up and running and want those test keys in there, right?
Yep,
So
yep.
they can just enable that secure boot and go. We promise we'll change the test keys out with our own keys later before shipping.
And then
But
they don't.
sometimes it doesn't
Yeah.
happen, right?
But
Yeah.
also, I think
Yeah.
the pressures
Yeah,
on
so
the more consumer PC enthusiast gamers, where we see that more often, right? Because they're trying to move a lot more quickly, I think, than some of the more traditional OEMs for enterprises.
yeah, one idea that I might suggest, I mean, obviously I'm speedballing here because the problem is very big. Like of course it's much harder than just the default password, right? But what if there would be
Yeah.
some configuration wizard? Like, okay, vendors say we wanna test it fast. Okay, here's a script which you can run. It will generate keys for you and pre-configure stuff to just run it, right? And then it will tell you what exactly it did, so that for production you can just go step by step and actually do it securely.
Yes. So I mean, I'm just having these discussions. Like I talk about this stuff all the time. I thought if you had like a first boot helper script that would take you through the first boot and guide you in setting up all the security features,
Right.
I thought that would be a great idea. So, hello, we've noticed you don't have platform keys configured yet. Let's help you with that. Okay, as soon as you generated, enter in your platform keys. Something like that. But yes, I mean, it's needed. We know it's needed. We know it's wanted. It's just a matter of putting something like that together.
Yeah, that makes sense.
Brian, did you talk about Black Hat and the research that came out recently? Was there anything that kind of went on your radar that particularly impressed you, or was kind of like, oh, I never thought that was even possible?
Related to the Black Hat recently?
Yeah, any recent research, Black Hat, DEF CON, or anything recently.
I mean, I've been surprised about some exploits in the past, like the logo fail one.
Yeah, I think you said that before, the logo here. Like, I never would have considered that the implementation of the logo would be something that there was an attack path for it. Yeah.
Now that was kind of an interesting one, and that surfaced due to a customization by one of the downstream partners that kind of opened up that exploit, that attack vector. Um, I think it allowed the customers to customize their logo.
Yeah.
So then you
Right.
have attacker controlled data being
Right.
uh, allowed into the logo parsers. But yeah, that was kind of a surprising one. Um, I don't know, Vlad, you found some good ones, right? For be on the BMC side.
Yeah,
That's
that's
how
where I
I
was
met
going. That's where
Vlad
I was going next.
years
It's
ago.
interesting to have both Brian and
Oh yeah,
Vlad
yeah.
on the show.
Yeah.
So let's
Vlad,
So
talk
you've
about that.
discovered
I
and disclosed
I, ca-
several BMC vulnerabilities to AMI. I just want to say AMI has been great to work with. Obviously, Brian's here on the podcast. You guys are
yeah.
always great to work with when anytime we're
Yep.
disclosing a vulnerability.
You guys are very good to work with too. You're very responsible when it comes to sensitive issues like finding vulnerabilities in vendors' products, and you're very conscious of reputational damage if they're not handled properly. So we love working with you. Um, that Vlad, I remember you brought some issues to our attention, and like the attack vector involved remote access. And I was like, well, this is kind of mitigated by the fact that all of these should be operating in secure environments.
Right.
And Vlad was like, "Oh no, we've identified BMCs connected directly to the internet, and here, let me show you this list." And Vlad showed him logging into or bringing up the login screen for one of them. Yeah, so do not attach your BMCs directly to the internet, folks. Do not do that. Vlad will find it.
Yeah. And it would be good if I find it. It will not be very good if attacker finds it, like
Right. It
actual
doesn't.
evil
Yeah.
guy, like my
Right,
evil
right.
twin.
Brian,
Yes.
It would
I
be
guess
much worse.
Brian, for the benefit of our audience, walk us through like what goes into the BMC side. We talked about UEFI and a lot of the components, but walk us through the BMC. It's not all that dissimilar to all the same processes you talked about are in place for the BMC software, but it's a different beast and animal all in of itself, right? Largely based on Open BMC.
True, it's firmware though. So if you're talking about the reactive security and proactive security stuff that we're doing,
Yeah.
we kind of work is like this in this decentralized model. We implement this horizontal function in the organization. So we're not a part of any BU, but we are more than decentralized. We're like a hybrid. So I do get into their workflows, like we use Jira workflows to extract all the remediation information. So we'll create security tickets, and then we have tools to scrape the information that they add to the tickets about the remediation, and we scrape that out into our vulnerability database, and that's kind of the data path. And then we talked about that other thing that we did with the customers. So a lot of those processes and tooling that we create, we expect it to be adopted by all the BUs. So in that way, they're somewhat similar. We do things a lot of similar ways. But with BMC, it's a lot of open source. You have a Linux kernel running in that. It's a lot more open source heavy. So we get heavy volumes of CVEs that comes from those open source
Right.
ingredients that we have to manage. So we do these CVE lists. So we don't curate a specific PDF for every OpenSSL CVE that's created.
Yep.
We tend to do custom advisories for the vulnerabilities found in AMI code, right? But a lot of the open source CVEs will put in CVE lists and distribute those lists, and it'll be a spreadsheet, and each row will be a CVE, and it'll tell you remediation information.
Right.
That's a little different with we do that with BMC. We're going to start doing it with the UEFI product too, but the OSS volume, OSS CVE volume is much less for UEFI.
Right. And the BMC
again-
ecosystem is similar to what we talked about before with the supply chains and various OEMs and customizations, kind of similar.
Right.
Yeah,
Yes,
so
yes, yes.
to step back a bit, again, I'm not sure how folks are familiar who listen to the stream. So BMC are actually normally running a full Linux setup. So this is just a full disclosure moment, right? So most BMCs that I have seen are some kind of Linux box. It's not just AMI, it's also OpenBMC, it's all of the stuff that forked from OpenBMC. So that's actually a lot of software if you think about it. Like if you take a Ubuntu-based image in Docker and just say, Docker, please tell me how many CVs are there, or some tools that actually can scavenge Docker for that. You'll find probably a couple hundred of them right out of the box, and that's for just, let's say, Ubuntu image, right? So yeah, it's very open source heavy. It's not just open source heavy, it's in general just heavy. So there's just a lot.
Yeah.
There's a lot of I didn't realize how much code was inside of BMCs, even though it's a slimmed down Linux, if you will. But if you ever want an exercise, go build an Open BMC image, a Yocto build on your machine. I think it's the only process that taxed my like 24 core system. And there's just a ton of different components. You know, Brian, we saw it when we were looking at, well, what's inside OpenBMC? What are all the dependencies? There's a lot of software in there that ends up customized on each individual OEM's platform, right? Very similar to UEFI. I'd
Right.
imagine you provide that software, they make customizations to it, and the like.
Yeah, and we can talk about some evolution there. It is heavily based on open source, and we're a goal of AMI is to embrace open source, and in doing that for all of our products, we're creating an open source variant. So this is kind of getting away from like the proprietary licensing model, and we're giving you a open source version of the firmware, which you can download and create that derived product on your own if you want, or you can partner with AMI and we can help you modify it and create that derived product with you. So we're using the OCP marketplace as a way to kind of facilitate this. OCP is great because you get a lot of security assurances with the marketplace. Like you have to complete OCP safe process before the product can be listed on the marketplace, and that involves third-party security reviews. So you get an added layer of assurance. So we're AMI is focusing on BMC primarily first. We have Tectagon and Apptio variants, but the focus is on OpenBMC right now. Not OpenBMC, sorry, OCP. It's OCP Mega Rack Community Edition.
Okay.
And that supports all your major silicon, like Nuvoton and ASpeed. So you get up and running like out of the box for all the major hardware. AMI is kind of acting like a custodian there, upstreaming, keeping that software current, resolving all the vulnerabilities. And they upstream like once every 6 months. So you got kind of like that custodian taking care of things. It's actually, and we get it building for all the silicon. So it's a lot of work AMI is doing there, a lot of value in there. So yeah, if you're interested in BMC product, take a look at that.
Yeah, I was impressed, Brian, I like the custodial work that AMI is doing for the BMC platforms, because you're really scrutinizing every vulnerability, trying to get that count down, providing S-bombs, doing all the right things
Right.
to make sure that
Right.
we're all poised to run more secure and provide integrity for that software that's so critical. I
Right.
mean, obviously the BMC is the highest privilege mode you could achieve on a system.
And to be honest, it's not
Yes.
just
And
that.
don't forget, go ahead.
Sorry, go ahead, Brian.
Yeah, BMCs are classically have very low visibility into them. Like normally you don't have any kind of shell on them, while it is a full Linux box. So if malware gets in there, it usually stays in there. So like it might go in open source, providing some community edition stuff. So this provides a lot of visibility. So and that's actually pretty great, because now vendors like us, for example, we can get a lot of visibility into what's running behind it.
Yeah, it's all about trying to arm the customer with great remediation and visibility into these systems, such as UEFI or BMCs, that traditionally don't have that visibility.
Yep.
I think it's one of the reasons why I'm so passionate about this, is because it's kind of like a dusty corner in most IT shops in an IT infrastructure, right? I'm sure, Brian, you see
Right.
that if you talk to any enterprise customer, it's like, oh, it's one more thing we have to worry about.
Yeah. Paul, you mentioned the custodian role. We also have a bunch of like regulations coming out with the EU CRA, Cyber
Yes.
Resiliency
Yep.
Act,
Mm-hmm.
and that custodian can help vendors with compliance with specifications such as that. So that's important. So what's really important? SBOMs, right?
Yes.
Reporting, like P-certs, uh, secure designs, like threat models. So you get a lot of that with some of these implementations like the OCP Mega Rack BMC.
Mm. And Brian, you're involved with the UEFI SBOM committee as well.
Yes, I'm a co-chair on that UEFI SBOM working group, and we're trying to take the objective of that is not creating a normative specification, but kind of creating guidelines for the supply chain on what a UEFI SBOM should, a compliant UEFI, UEFI SBOM should look like. And we're taking that CISA framing document and then kind of shaping it and going, okay, well, their minimums are that. What does this mean for a UEFI product? And we kind of like personalize it for UEFI. So we
Right.
have those meetings every 2 weeks, and we're kind of going through trying to decide what this UEFI SBOM should look like.
Right, because there's a lot of responsible parties in there that have to create an SBOM for their components that then get glommed on to the next, entity in the supply chain, and you're adding
Right.
on to that SBOM, right? It's kind of like a cumulative SBOM that I've seen in other kinds of embedded software as well.
Yeah, it's great if they all have the same type of information, so you can create that aggregate SBOM at the end of the supply chain, lump all the upstream suppliers SBOMs together, and
Yeah.
they all kind of have the same information.
And is the goal that like the end user would also have access to that SBOM to use it as a source of like, oh, there's some new UEFI thing, I can go query some SBOMs, or are we not quite there yet?
You could. So you're talking about an SBOM in the public domain.
Yes.
So
Yeah.
part of the discussion is like different levels of SBOM. You have one for the public domain, and you have a more like an NDA version SBOM where it has some of those NDA ingredients listed. But I don't know. I don't like it like a gamer. Are they going to be like looking at SBOMs
Yeah,
and kind
probably.
of tracking what vulnerabilities have been discovered against their ingredients? I don't know.
Yeah, it's definitely an enterprise play for sure.
Yeah, yeah, and it's going to be a requirement, right? It's going to be a requirement.
Yeah.
Got to provide those estimates.
Right. Well, awesome. Vlad, any last questions for Brian?
Just thinking about it, I don't think I have any. I think we discussed a lot.
We certainly did. Brian, anything else from the AMI front that you want to share with our audience?
I think we covered it, Paul. We can do another one if you want to. I'm happy to do it.
Yeah,
If we think of
absolutely.
something.
And now, Brian, your location, you look like you're in like the AMI fortress right now, which is pretty awesome.
Yeah, this is the AMI Central Security Command Center room. This is like if something goes down, all the stakeholders gather in here and we figure it out. It's used by enterprise security for like global IT issues a lot.
That's
So
awesome.
it's got
That's
TVs
awesome.
everywhere. It's got the
Yeah.
beverage fridge.
It's very fitting. It's very fitting. Well, Brian, thank you so much for appearing on Below the Surface today.
Thank you for having me. Good to see you, Vlad.
Thanks,
Good to see you
guys,
as well.
and thanks everyone for listening and watching to this edition of Below the Surface. We'll see you next time. Just thinking about it.